What is up, math superstars? In this edition of Mr. Peterson Presents, we're talking about how to find simple and compound probability. So probability is a lot of fun when you're playing games, and so you can figure out your chances of winning using the skills here in probability. So let's go ahead and take a review here of some keywords that you will see in dealing with probability. And so here we're given a number line and we have some percentages 0% to 100%. If your probability of winning the game is 0%, it is impossible to win the game. And if your chances of winning are 100%, you are certain that you are going to win the game. Some other key ones here, 50%. It's equally likely that you will either lose or that you'll win. So 50-50 chance, not really sure, but we'll kind of go for it. 75% is somewhat likely, and so the more we go toward certain, the better your chances are of winning. But if you're down here at 25% and your chances are going toward impossible, there is a less likely chance of you winning. So when it gets closer to 1, you have a better chance that it's going to happen. So I'm going to write here, you have a better chance. And if it's closer to 0, the probability is less likely it will happen. And so here's actually how you can figure out probability of some different events here. And so we have a deck of cards. So in our deck of cards, we know that there are 52 total cards in the deck. And the goal is, I'm going to circle this part here, we have to take any card from the deck and we have to figure out what our probability is of drawing an ace. So the way we can do that, the way it's written out in math, is you have the P of the event. So the P stands for probability, and the event in this case would be an ace. So I'm going to write that as the probability of an ace is equal to, so here you have the denominator here. So our denominator, this is the number of outcomes in the sample space. So all that's saying is that we have 52 cards. So however many the total is you're playing with. So we're playing with 52 cards. In the event of drawing an ace, there are 4 aces in a deck. So there's 4 aces in a deck. So 4 is going to be our numerator. So the probability of drawing an ace, we write that as 4 over 52. We can simplify that to 1 out of 13. So every time that there are 13 cards, the probability of drawing an ace should be about 1 card. You might see a spinner. So in a spinner, it says in this example, there are 6 equally likely outcomes in the spinner. So we have to find the probability of spinning a bee. So what we do is we write that, we have the probability of letter B. This is the way we start that off. So P is probability, the outcome is the B, equals, and so we have to count up how many total spaces there are on this spinner. So we have 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. And letter B only shows up once on our spinner. So we're going to put that in our numerator. So we can say that in the math terms of our game here of the spinner, the probability of spinning a bee would be 1 out of 6, or 1/6. So here's the next spinner. So using the same spinner, what's the probability of spinning a consonant? So we're going to write that as the probability of our consonant. So we're not looking at the vowels. There are 6 possible outcomes, and let's use our consonants. So B is a consonant, C, D, and F. A and E are vowels. So we say that the probability of spinning is 4 over 6. And when we simplify that, that simplifies to 2/3. And so every time that we spin, we have a 2/3 chance of landing on a consonant. So that's somewhat likely to happen. So now if we roll a die, so we have a cube, a dice that has numbers on it. So probability of each vent, so we're going to write that as a fraction and then a decimal and a percent. So this cube here, 6 sides, so labeled 1 through 6. So what's the probability of rolling a 3? So if we have, for letter A, we have 6 sides, and roll 3, there's only 1 3 on there, so we write that as 1/6. The decimal form, 1 divided by 6 in the calculator, gives you a nice decimal here of 0.167, and our percent, there is a 16.7% chance of rolling a 3. So for letter B, the probability, so there's still 6 sides, of greater than 4. So we're talking about just 5 and 6 here, or greater than 4. So we have 2 possible outcomes. We can roll 5, we can roll a 6. That'll be 2 over 6. When we simplify that as 1/3. So we write that as a decimal, 0.33, and it repeats, so you can put the line over it. But as a percent, you have a 33.3% chance of getting a number that is higher or greater than 4. So let's start with the last one, even. So we know that there are 6 total. Probability of the even, so there's 2, 4, and 6, so there's 3 chances there. That simplifies to 1/2. So you have a 0.50% chance, or you have a 50% chance of rolling an even number. So here we're trying to figure out the probability of multiple events. This is the likelihood of more than one event occurring. So previously we've been just talking about one event. Now we're talking about more than one event occurring. And so when we deal with independent, so this is a key word, highlight that in your notes, circle it, put a smiley face next to it. But the independent events, this is where one outcome, so your outcome of your first game does not affect the outcome of the second game. So these are 2 totally separate games, or you might play one game and then say if you're dealing cards, you might put the card back in, but in this case, this is where it does not affect the outcome of the second event. So here, for the probability of compound events, so we're going to deal with 2 totally separate things, but we're going to be given some information. So we need to figure out the probability that both letters, so letter that we'll pull out of our tiles and the letter we spin with, are both going to be vowels. So let's go ahead and do the probability of selecting a vowel from the tiles. So let's count the number of vowels we have. We have A and we have E, are the only 2 vowels listed. So that'll be 2 out of 1, 2, 3, 4, 5, 6, 7. So the probability of selecting a vowel out of our tiles here is 2/7. We know that we're multiplying by the vowels on our spinner. So we find out there are 2 vowels on the spinner times 6. We can simplify that to 1/3. So the probability now of selecting both letters are vowels. So what we can do is we can do 2/7 times 1/3. So multiplying fractions, multiply our numerator together to get 2, multiply our denominators together to get 21. So the probability of both letters being vowels in this game, you have a 2 out of 21 chance of that happening.